This is Chapter 7-2 Reflections. Please copy your cards. To begin, let's start with the definitions. And we're going to start reflection. Just a reminder, reflection is a type of transformation. There are 3 types of transformations. We talked about it in 7-1 video. It's a reflection, a rotation, and a translation. Those are the 3 types of transformations. Today we're going to look at the reflection. A reflection is a type of transformation that produces a mirrored image using a line of reflection. Our line of reflection is a line used to produce a mirror image of a pre-image. So for example, on this drawing here, I have point P and then P prime, point P prime. Line M is my line of reflection. A line of reflection means, let's say if I have a hand up here top above line M, and I have a hand, if I want to make an image of this pre-image, my first hand, if I'm reflecting over line M, if I were to fold it downward, okay, if I'm using that as my point of reflection, that means every point will have a twin. We'll look at that more when we look at shapes, but right now we're talking about a point. If point P is not on line M, then that means this line of reflection, line M, is a perpendicular bisector. So, in other words, the distance from point P to the line is exactly the same distance from line M to P prime. Same exact distance. So if from point P to the line is 2 inches, that means that from the line M, or the line of reflection M, to P prime is also exactly 2 inches. Okay, the distances will be exactly the same from one another, from the line of reflection. Okay, it's perpendicular because the distance from point P over is going to form a right angle. And again, same thing here. P prime is going to, that line M is going to be perpendicular. The distance from the line to the point is perpendicular. Okay? Moving on. If P is on line M, what happens? Let's suppose here, and I'm going to erase some of this so you can see it a little more clearly. Let's suppose I still have the line of reflection M. If P, the blue, is on line M, if I fold on line M, or the line of reflection, that automatically means that P prime is also going to be on the same exact line, in the same place. If they're both on the line, if I fold on the line of reflection, that means the prime will also be in the same place. So P, in that case, will be equal to the prime. If and only if the original point lies on the line, then that means that the image will also be in the same place as the pre-image. Okay? Now, 7-1 deals with reflection theorem. A reflection is isometric. They have isometry. And we talked about in 7-1 video, isometry means same size, same shape, same length, same everything, it's just in a different location generally. That's it. So reflection theorem says a reflection, if I'm talking about that type of transformation, a reflection is going to be isometric, or has isometry. Next item of business. If I have here a line of symmetry, we're talking a little further about it. Again, as I stated, a line of symmetry is a figure that can be folded in half, and each piece have its own exact twin or mate. Or in other words, a figure can be mapped. We talked about the word mapped, or moved onto itself by a reflection line. So let's say, for example, I have this shape here, this figures, A, B, C, D, E, F. Let's say I want to reflect it over itself and look at the lines of symmetry. For example, if I redraw and look at lines of symmetry, let's say I were to fold and create a line of symmetry from A to D, like here drawn. If I were to fold it in line, or in half, based on the line of symmetry, that means that F will have a twin. F's twin is B. Look here, here's the line AD drawn, the line of reflection in blue, AD, the line of reflection AD. If it's folding up and downward along, and I'm going to delete this one off just so it's a little easier to see. If I have this reflection line and I'm folding it top to bottom or bottom to top, B and F are twins. It has a mate, okay? So there's a line of reflection. C and E are actually twins if I were to fold this downward or upward. Those two are twins. There's also some more twins. If I were to fold along the line of symmetry AD, let's say I'm looking at this point. This point has a twin if I fold it downward. Its twin will probably be right about there. I can also look here. If I had put a point at this particular place, this point will have a twin if I fold along the line of symmetry. Okay? Line of symmetry is kind of like the line of reflection almost. When you talk about line of symmetry, the difference between a line of symmetry and a line of reflection is the line of symmetry means I'm drawing through an object and I'm saying that each point has a twin or mate. Okay? In this case, we have numerous. If I put a point here, there's a twin there. If I put a point here, there's a twin there. Everything has a twin. So this would be my line, AD, of symmetry. Okay? There are more than just that one line of symmetry. For example, I can put a line of symmetry here. If I look at this line of symmetry, and I'm going to delete this off. If I look at this blue line as the line of symmetry. Remember, line of symmetry means I'm drawing through the object, and that object is going to have twins. Okay? Line of reflection means I'm going to actually go over it. Okay? So this line of symmetry means I'm drawing through the object A, B, C, D, E, F. And each point will have a twin. So if now this is my line of symmetry, that means that B has a twin. Its twin now when I draw my line of symmetry is now C. Whereas before when I do AB, F was its twin. If this new current line of symmetry is drawn here, that means A has a twin. Its twin, if I'm folding left over right or right over left on this line of symmetry, A's twin is going to be D. F has a twin if I use this new current blue line. Its twin is point E. And again, as I stated before, I could have this be a point here. If I'm folding, its twin or mate will be right there. Again, this is my line of symmetry. You have plenty of lines of symmetry that can be drawn. So here we have just two lines of symmetry drawn on this particular example. Now let's look. Whenever you have more than one line of symmetry, you can calculate the angle of measure between each line. So let's say I want to find out what's the angle in between all of these. First of all, if you have lines of symmetry, all of the angles will be the same measure. And you can calculate what angle of measure it will be for each of these. Okay? So in this particular shape, and I'm going to see if I can copy it. So that was the original shape. Here we have. All right. Now, when I look here, I have several lines of symmetry. Remember, lines of symmetry means I'm going to draw through the object, and each point on the object will have a twin. So two things happen with the line of symmetry. I create the line of symmetry, and that means that each point will have a twin. So the first line of symmetry I drew is here. Okay? That means if this point here has a twin, if I fold along that line of symmetry, that twin is right there. If I use this as my line of symmetry. Okay? That's my line of symmetry. This twin will be there. Okay? Next item of business. Let's suppose I use this as my line of symmetry, because I can fold this way now. Okay, these two will be twins. These two will be twins. And just a reminder, we talked about it in the previous one with this point P here. P and P prime here, if a point lies on a line, then that means it's automatically going to be its own self's twin. So for example, if this is my line of symmetry, let's say I'm drawing this point. Where is its twin? Well, its twin is actually in the same place because the point is on the line of symmetry. Okay? So backing up just a bit, we can see that this particular shape has several different lines of symmetry. And I see 1, 2, 3, 4, 5 lines of symmetry here. Okay? And looking at this 5-sided pentagon on here, we can calculate, as I stated, the angles in between by using an equation. So if I want to know what's the angle of measure, simply done. Because it's a regular pentagon, it has 5 lines of symmetry, we can calculate the angle of measure between each line by n times the measure of angle A equals 180 degrees. N is just the number of lines of symmetry. And in this example, the number of lines of symmetry is 5. We're trying to find out the measure of angle A. And the measure of angle A just means what's the measure in between each of those lines of symmetry. And it's always equal to 180 degrees. Okay, and again, where n is the number of lines of symmetry, and the measure of angle A is just equal to the angle measure between each line. So this is the measure of angle A. How far, all of these are the same exact measure, and they're all considered the measure of angle A because they're going to be same value. Here's the equation. N times the measure of angle A equals 180 degrees. Now by substitution, n is equal to 5. We're solving for the measure of angle A. And we set it equal to 180 degrees. I need the measure of angle A on the side by itself, so I'm going to divide both sides by, of course, 5. So I'm left with the measure of angle A equaling 36 degrees. So we'll find 36 degrees being in between each of these 36, 36, 36, 36 degrees, 36 degrees, 36 degrees, 36 degrees, all the way around. And we will be working on this further in class.